Okay, this video is about the properties of logarithms. So the change of base formula is helpful because it helps us when we have a base that's not just a base 10. So with a common log, let's say the base is b of a. So I take the base, put it in the basement of the fraction, and I would put in the calculator the log of a divided by the log of b, whatever the base was. Or you can use a natural log, for instance with numbers, log base 3 of 7. That goes on the bottom, this goes on the top. But I would use a natural log. I can use both. Natural log of 7 divided by the natural log of 3. Either way, you're going to get the same answer. So the problems will read like this. Rewrite each logarithm in two different forms using the change of base formula. So this just says to rewrite it. Yeah, you can go ahead and calculate it if you want, but it'll be the same. Log base 4 of 25. I can rewrite that as the log of 25 divided by the log of 4. Or with natural logs, the natural log of 25 divided by the natural log of 4. Either way I type it in the calculator, with logarithms or natural logs, you're going to get the same answer. Example 2, same idea. Log of 12 over the log of 2. Or with natural logs, the natural log of 12 divided by the natural log of 2. Okay, that's all you got to do. That's what the change of base formula means. You can use common logs or natural logs. Okay, properties of logarithms. Product rule. Product means you multiplied, right? So look, log base a of any two numbers multiplied, u times v, it can be rewritten as the log base a of u plus the log base a of v. Notice the bases are the same. You just separate them out and then you add your results. The quotient rule. Remember, product means multiply. Quotient means divide, right? So division, log base a of something divided by something else, u divided by v. Log base a of u subtracted from, or minus, the log base a of v. So you're subtracting on quotient rule. The power rule says the log base a of u to any power can be rewritten as that power n times the log base a of u. So basically you're just taking that power, moving it to the front of the equation. Alright, so how do you use these guys? Well, a lot of different ways. For instance, on number 3 here, log base 5 of cube root of 5. Well, let's think about this. The log base 5 of the cube root. Remember the cube root, any kind of root is a fractional power. Cube root is 1/3, square root is 1/2. So this can be written as the 1/3 power. So I'm going to use my power rule. Notice what it says. Take the power, move it to the front. Move it to the front. So what I have is 1/3 times the log base 5 of 5. Well, remember what logarithms say. 5 to what power gives me 5? Well, all of this I can solve. 5 to what power gives me 5? Well, that's just a 1. 5 to the first power is 5. So 1/3 times 1 gives me the solution of 1/3. Okay, look at this one. This is another power rule problem. Moving my powers to the front, I have 6 natural logs of e minus 2 natural logs of e. Moving those powers to the front of each part there. Think about what's the natural log of e? Well, remember the base of natural log is e. So it's saying e to what power gives you e? That's a 1 as well. So 6 times 1 minus 2 times 1. 6 minus 2, which we all know is a 4. So you can use these power rules, any of these rules, to simplify an equation. Try some more examples. Okay, so some of the problems will say to expand it. So look at what's happening here. Things are being multiplied. You have 5 times x cubed times y. All right, so let's expand it. The product rule said you're going to expand it with plus signs, right? Same base, just a bunch of plus signs. So I'm going to do the log base 4 of 5 plus the log base 4 of x cubed plus the log base 4 of y. Now, you always want to look and see if there's anything else you could expand. Notice this x is to the 3rd power. What did the power rule say? It says I can take that power, move it to the front. So I'm going to continue on. Log base 4 of 5 plus 3 times the log base 4 of whatever x is plus the log base 4 of y. I can't solve this any further because I don't know what x and y are. So I leave it, oops. So I'm going to leave this in expanded form. Sorry, that didn't work right. All right, look at example 6. This is a division problem. So this is quotient rule. Remember quotient rule said division turns into a subtraction problem? So let's simplify some things first. Okay, natural log. Anything in a root you want to rewrite as a power. Remember, a square root is a 1/2 power, so I have that over 7. Quotient rule says whatever's on top subtracts, or bottom subtracts from the top, keeping the bases the same. So I'd say the natural log of 3x minus 5 raised to the 1/2 power minus the natural log of 7. Now I'm not quite finished because I have a power sticking out here. I need to move this power to the front based on the power rule. So my final answer would be 1/2 the natural log of 3x minus 5 minus the natural log of 7. This is what they mean by expand your answers out. Okay? Condensing. All right, this, just like expanding, you're going to condense it down. Look at what's happening. This plus sign should be your clue that you're going to be multiplying. All right? And look, that 2 in the front means it's going to go back to being a power. So the bases of the logarithm are the same. So it's going to be a natural log 4x times, not 2y, but y squared. Okay, remember that 2 represents a power that got moved to the front. So 4x times y squared, or you could write it natural log of 4xy squared. Either way is correct, as long as you have your power correctly in there. Look at number 8 here. Lots of stuff going on. You have a minus, meaning there's going to be some division, and a plus, which means there's some multiplication here. So let's deal with the parentheses first, like always. This 2 in the front, remember, is a power that was up here with the y. So what I have is the log of y squared times, that plus became a times z. Okay. All of that is being subtracted from 2 logs of x. Well, that's really the log of x squared minus all this stuff. Now I take care of the minus sign. That's really the quotient rule. Remember, it said to subtract if it's divided. So if I find my final answer, if I condense it, it's the log of x squared divided by, instead of minus, y squared times z. Okay, so that's my quotient rule and product rule all in one. All right, so we can use these properties to help us solve equations. All right, so look at number 9 here. Let's just split the screen here. Number 9. Log base 3, I have 9 cubed times 4 squared. All right, so product rule says if it's multiplied, I'm going to make it a plus sign. So I'm going to make the log base 3 of 9 cubed plus the log base 3 of 4 squared. Well, let's move our powers to the front. So 3 times the log base 3 of 9 plus 2 times the log base 3 of 4. All right, well, let's figure this out. Log base 3 of 9. Well, 3 to what power is 9? 3 squared is 9. So we know this is 3 times 2 plus 2 log base 3 of 4. Do we know what the log base 3 of 4 is? No, but you can leave it like that. So we know this is 6 plus 2 log base 3 of 4. And you could go ahead and solve this in your calculator if you wanted to. But in your problems today, you won't be able to because there'll be some variables that you just don't know. So it's okay to leave it partially. But in this case, you probably should. Example 10. Look at this. So using my change of base formulas, I can solve this. This is back to the very first thing we did here. We said it would say the log of -2 over the log, log of -8 over the log of 2. Well, right here's a problem. We said before you cannot take the logarithm of a negative number. So this does not exist. So you can't take that, so you can't divide that, so you would say does not exist. Okay, so just be aware if you're ever asked to take a logarithm of a negative number, it can't happen. So you put D and E, does not exist. Okay, for the whisk, I want you to solve this, and I want you to solve it all the way down to a number. Okay, all the way down to one whole number that you can put into the whisk. All right, if you have problems, bring them to class. We'll try to solve them there. Thank you.